TEC10024. Here is my project for the DIY course, week 5 assignment 4. As you can see on the screen, I have already started running running the simulation for the first part of the project, because it takes quite a while to settle down at its stable speed. But while it's simulations running, to just break it down, so this is the driver circuit, and here are these DC motors. These are logic gates, and we are primarily using only this DC motor through a channel, and we are using pins 12 and 8. Actually 8 is connected to the brake, and 12 is connected to the PC motor. So I have pinned that in the source code, but we can't see that because it's running right now. So basically we keep the pin mode of 12 as high because we want the DC motor to run, and we keep the pin mode of 8 as low. Low because we don't want brake, so that's why it's switched off. It's low, and it keeps running and initialized a variable called PWM, which is basically the variable that we use for pin 6. We analog write pin 6 with the PWM variable, which is basically like a variable that can be used to calculate rotations per minute of the DC motor. And for this case I have used a PWM equals 150 initially. So as you can see, the DC motor is somewhat stabilized here at 18.9. So I am going to at around 19 I am going to stop the simulation right here, and so let's just check the source code for the second. So like I said, PWM is 151, and we have been the 12th pin, 8th pin, and 6th is where we put the variable. So let's just make changes from 150 to say 50 for the sake of changing and seeing what it looks like. So let's just compile it quickly, and after it gets compiled, let's go ahead and run the simulation. So as you can see again, the speed of the DC motor is increasing steadily. Again, it will take some while, take some time, and for it to stabilize, but essentially it should stabilize at half the speed of not half, actually that 1/3 of the speed of when we use PWM of 150. But due to the internal factors within the DC motors, it doesn't actually going to take it's actually going to take a while for this, and but as you can see, it's working, and that's my first part of the project for this assignment. For the second part of my assignment, I have created the project on the node thread as shown on the videos. Firstly, as you can see here, there's a slider for water level in the water level group from having a range of 0 to 100 output, which is continuous while sliding, and there is a gauge here that shows that which shows a graphical representation in decrease and increase and decrease of the slides. We have kept the color gradient in such a way that 0 to 30 green, 30 to 60 yellow, and above 60 it is red. And second part of this, it's gas pressure and gas pressure controller. So for the slider again, here the range is 0 to 40, same output type, and the labels gas pressure controller. And for the gauge, instead of a normal gauge, this time we have so it's not again it's a chart, and the type of charge we use is a bar chart. So so these are the settings of my chart itself. Same range for the y-axis 0 to 40. Let's see what it looks like. So the gas pressure controls will start below. That's how the graph changes while we increase or decrease along the slider. For the gas pressure controller, for the water controller, as you can see, from till 30 it's green, beyond 30 it's yellow, and beyond 60 it's red. So this is how it works. and thank you.